Good day, chemist in Japan de gozaimasu. Well, I have a new computer that I'm using. This is the first time I've made a video with it, and it's a little bit different, actually. I think the camera is better in this one than in the last MacBook Pro that I had. But I'm going to go ahead and post a video that I made, and I'm not very happy with it. And in fact, I may eventually remove this video and replace it with a better version of it. But I wanted to make this kind of video, this kind of chemistry video, specifically because of the other kind of videos that are on YouTube. In this video that I very hastily and quickly made and didn't really think about how to make it look pretty or flow or anything like that, it's a really crappy video, I'm telling you now. It's going to be a crappy video. It's not edited well, it's not put together well because one, I was in a hurry during the reaction, and two, there were other people in the lab talking to me occasionally. So it wasn't the best setup for creating a video. I might go back and redo it. But this video features the use of sodium metal. Now, if you've been on YouTube for any period of time, you probably know that there are a plethora of videos that do nothing but throw sodium in the water, or potassium in the water, or any of the alkali metals into water and watch them burst into flame. Because the alkali metals react very violently with water, and as you go down the period, they become more violent in their reaction. But sodium itself is pretty violent when you throw it into water. But believe it or not, throwing sodium into water and watching it pop and catch on fire is not the only use that sodium metal has. It actually has valuable, worthwhile uses. And today, in this video, I actually show you one of those worthwhile, meaningful things that sodium can do. But I feel it's important to, yes, it's fun to watch it pop and go on fire and stuff, but I think in the broader scheme of things, there needs to be a little bit of balance, and here's the balance. This is the actual scientific use of sodium, and that is to make alkoxides, which is you take an alcohol and deprotonate it and make it into a base. So in this video, I'm going to take ethanol, the kind of alcohol you actually can drink, ethanol, and I'm going to react it with sodium to make sodium ethoxide for a different reaction that I'm going to do with it. The kind of reaction that I'm going to do is a Claisen condensation, and I'll talk about that in a different video about reactions, but it's called a Claisen condensation, and basically what I'm going to do, I'm going to take a ketone and an ester and combine them together and condense an alcohol. So if you want to know more about the Claisen condensation, you can look that up on Wikipedia, but I may make a video sometime later about it, I'm not sure. But like I said, this video is very bad. It was not, I didn't even think about making the video until after I'd already started doing what I was doing, and I made it quickly, and like I said, it's bad. But if you find it enjoyable, then that's good. Alright, so at least you get to see sodium reacting, although it's not like it is with water. Thanks for watching. Alright, good day everyone. Chemist in Japan de gozaimasu. And I am doing something today which I'm trying to decide whether I'm actually going to post this video or not, but I'm going to try to make it because I'm doing something that most people would consider fairly dangerous. I'm going to make sodium ethoxide because I need it for a reaction, but I have to make it, and you make it from this right here, from sodium. That's in kerosene, yeah, and you can see the surface of it's oxidized, but I started cutting on it, and I'm going to actually take it out and weigh it and use it, but you can see right there the unoxidized surface of the metal inside the kerosene. So I'm going to finish cutting this. I started cutting it. I'm going to finish cutting it. I'm going to put the camera down here and see if how well this works. I don't know how well it's going to work, but I'm going to set it right there and finish cutting and removing this piece, and then you're going to react it. Sodium is these vinyls are very soft. It's in kerosene because it's very reactive to water, I'm sure. I'm sure you can find a multitude of videos here on YouTube to demonstrate that. Okay, so I have the piece dislodged. Now, I think I do. Maybe I don't. Yeah, I do. Alright, so I'm going to turn this around the best I can in here. So, it's really hard to see. But, that's the unoxidized surface. It's very shiny on there. But over here I have another container of oil that I'm going to take this out and put it into. And I'm going to proceed to cut it so that I can weigh it out for my reaction. I need just a little bit more oil. Now, as a safety precaution, I actually do have someone else in the room with me. And there's a fire extinguisher. Although, if the hydrogen gas that evolves from the reaction decides to catch on fire, it's not going to be on fire for long. What? I got to talk to the camera.
I didn't realize you were loud here. I was like, you're not talking loud enough for me to hear you, so I'm just not going to answer you.
You're just not going to answer me, okay.
I'm just not going to answer if you can't talk loud.
See. Alright, so I now have the piece out here. Now the sodium, when in the other package, it's contained in kerosene, but here it's in I put it in mineral oil. But you can definitely now see that this side, that's the oxidized side, and that's the freshly cut side. Let me see if I can move it closer. I'm trying not to touch my camera as much as possible because of the oil. But so that's what it looks like. It's nice and shiny. And I'm now going to cut off the oxidized places, and then I'm going to cut it into smaller pieces, much smaller pieces, and weigh them, and try to, as best as I can very quickly, to weigh it and get it into the reaction before it has a chance to oxidize too much. So we'll see how this works, and see where I can put my camera so that you can see that. So trying to get all the oxidized stuff off because that won't react, and I need to make sure I have enough. Now I'm going to try to make enough of sodium ethoxide here so that I don't have to keep making it over and over, because I have to do this reaction several times with different materials, and I'd rather not have to cut this over and over and over again, so I'm going to do my best to make a good amount of it right now. Alright, so I have that piece, and I need to take it over to the scale now and weigh it as best as I can really quickly, and then get it back into the oil. So let's go do that next. Okay, so what we have here is the sodium is there. This is a beaker with hexanes, and that's my tools over there. So what I'm going to do is, very quickly, I'm going to take the sodium out of there, dip it in the hexanes to remove the oil, put it on the scale, which is already taired and has a piece of weight paper ready to go. Rinse it with hexanes, weigh it, and then get it back into the oil as quickly as I can. Unfortunately, there's not a great place to put my camera here, so we'll just try this. Alright, now that I have 7.5 grams here weighed out, I'm going to take it and cut it into very small pieces. And I'm going to drop these very small pieces into the reaction flask. I'm not going to add it all at one time. Add it very slowly in small pieces and allow it to react. She here? That is going to be interesting. And now that it's at room temperature, you can kind of see there a piece of sodium. It's floating there in the ethanol, but perhaps you can see, it might be difficult when it comes around, but there are bubbles forming on its surface. You can kind of see them as they float off there. It's difficult to see, I think, but maybe you can see the bubbles on its surface, and that is the ethanol reacting with the sodium, the metal, and making the base, the alkoxide, and then hydrogen gas is what's given off. So basically what it is, it's two moles of ethanol react with 2 moles of sodium to make 1 mole of hydrogen gas. And you can see it's being expelled there. If this gets too warm, I'll put it back in ice water